Are carbohydrates addictive? What do you think? A lot of this may have to do with your personal experience with food and potential for food addiction. And it's one thing to say food has addictive tendencies, or you may feel like you're addicted, and it's another thing to say it's an official definition of addiction. So why that might matter for regulatory rules and laws and things like that, what I'm most concerned about is what's happening to you as an individual. What's happening to my patients as an individual? Are they showing addictive tendencies to the food they're eating? And what role do carbohydrates play in that? And now we have a new study giving us more information about how carbohydrates affect the brain reward centers, which are similar to addictive type drugs or addictive behaviors and what they do to brain reward centers. I'm Dr. Brett Scher, the medical director at DietDoctor.com, and I want to talk about this study. And we have a bit of a treat because I'm going to explain the study, talk about what I think its implications are, and then we actually have an interview with the lead author. So the lead author is Dr. Laura Holsen. She's a PhD and assistant professor of psychiatry at Harvard Medical School, and she focuses on the model of brain dysfunction and as it relates to appetite dysregulation. And she teamed up with Dr. David Ludwig to do this study, which we recently wrote about at DietDoctor.com, and the study was published in the Journal of Nutrition. What they did was they took 72 overweight volunteers and randomized them to one of three diets. It either had 60% carbs, 40% carbs, or 20% carbs, with fixed 20% protein. So what differed then was also the fat. So either 60% carbs, 20% fat, 40% carbs, 40% fat, or 20% carbs, 60% fat, with the protein being held stable. And here's one of the most amazing parts. For this 20-week study and 72 people, they provided every single meal. That's a pretty impressive undertaking. I mean, that's over 2,000 meals that they provided to the participants of the study. And that's important because on a lot of dietary studies, you tell them to eat a certain way and they go out and you're not sure what they actually ate. But this time you are sure what they ate because you actually provided them with the meal. So pretty impressive undertaking. And what the volunteers in the study did was they underwent MRI scans, a special scan of their brain, to see like where the blood flow is, to see which different parts of their brains are being activated, both after a fast and 4 hours after eating their respective meal. And what they found was really interesting, that when you compare the 20% carb group to the 60% carb group, both fasting and after eating, there was a significant difference in the way their brain lit up in these reward centers. So there's one specific reward center called the nucleus accumbens. 4 hours after eating, there was 43% more activity in the 60% carb group than there was in the 20% carb group. So that suggests this acute effect that stimulates your brain reward center. Well, also in the fasting state, before they've had a meal yet, the people who were in the higher carb group also had increased blood flow to the hypothalamus, suggesting that there's both a chronic effect and an acute effect to the higher carbohydrate diet. Now, they also had some interesting findings as it relates to insulin, which I will let Dr. Holsen explain in our interview, which also are interesting as it applies to addiction. But so what is my take home for this? And you're going to hear me ask Dr. Holsen some of these same questions, but does this prove that carbs are addictive? I certainly don't think so. It doesn't prove that, but does it suggest that they can have some capabilities to provide some addictive type behaviors or to increase your cravings or to maybe sort of what we can say is hijack your weight loss, right? And it's certainly possible because if they are stimulating reward center, if they are making you crave more and want more, that's obviously a bad thing for long-term weight loss. Now, does this happen to everybody? No, definitely not. And that's the other interesting part. Like you can look at people, like I mentioned with the blue zones or in different societies where they maybe don't live in our traditional and American Western industrialized society where they have high carb diets and they succeed with weight loss, where they're, living a lifestyle that allows them to do that. But yet there are others who, by their own accord and by a physician working with them, you can see the more carbs they eat, the more cravings they get, the more they overeat. And so there are people who are more susceptible to this. And I mean, you could say, could this type of brain functioning MRI scanning help someone learn one way or the other? Okay, maybe it could have that tool. But more importantly, I think is people being aware of it and being aware of how you can potentially change your diet to lower those cravings, lower the reward stimulation, lower your propensity to overeat by maybe reducing the carbohydrates. For some people, I think this study shows that that could potentially be a big benefit. So that's my take home. Hopefully this helps you. And now stick around for our little extra treat here, because now we're going to have the interview with Dr. Laura Holsen, the primary author, and get some of her insight on what this means to her, why she wanted to study this particular topic, what she thinks the next steps might be, and what she thinks the take home might be for you. And having her answer the question, are carbohydrates addictive? So Dr. Holsen, it's a pleasure to be able to interview you about this study that you were first author on. And I'm curious, like, what was your motivation really to do this study, and what was the main question you were trying to answer by doing it?
Yes, it's great to be here. So my lab is focused on understanding kind of the neurobiological mechanisms that drive eating behavior, weight gain, obesity, as well as those that contribute to intentional weight loss. So we know that individuals can lose weight on different diets, but it's really challenging to maintain that weight loss. And that could be really frustrating for an individual to have lost all this weight through lifestyle modification only to see it be regained over time. And it's a really compelling challenge to help kind of try to solve, because as you are well familiar with, research by our collaborators, Doctors David Ludwig and Kara Ebeling, has shown that some diets, which are high in carbohydrate content and low in fat, contribute to this phenomenon of weight regain. And in our previous study together, we found that if you eat a single meal that's high in carbohydrate content, this results in significant increases in activity in regions of the brain associated. And so that led us to question whether, on a broader level, if a long-term high carbohydrate, low-fat diet could induce similar changes in brain reward regions, resulting in increased craving for high carbohydrate food. These kinds of studies looking at the long-term impact haven't been done.
Yeah, and I think you did a very good job addressing that, looking at the 20% carbs, 40% carbs, 60% carbs, and that you provided all the meals. Like that's a Herculean step in a study to provide all those meals, but so important so you know exactly what they're eating. So I mean, we talk about carbs, we talk about it as like one thing. And so as I already explained in this video, that the 60%, the group with the 60% carbs did have more of activation of this reward center in the brain, the nucleus accumbens. But what about the carbs, right? They're not just one thing. So did you try and control for like the type of carbs, the quality of carbs to see if that made a difference?
Right. So we didn't vary that. So the quality of the carbohydrates was very well controlled. I think kept constant across all diets was about a 15% kind of added sugars. And otherwise, it really varied in the amount of the carb you got. So, for example, if you look at some of the sample menus that were provided for this very rigorously controlled study, one group got this much of a whole wheat English muffin, and this got slightly less of that amount, and then the other group didn't get one but got something else. So the carbohydrate content and quality was really well controlled.
Yeah. So if you just take this on face value, that the higher carbohydrate diet had a greater activation in the brain reward center, does that prove carbs are addictive?
Ooh, great question. I don't think we can answer that question with this study. So I think what we can say is that carbohydrates stimulate pathways in the brain associated with reward in a manner, to some extent, that is similar to that of drugs of abuse. And although we did not directly test this, we would speculate that such an impact on these brain reward pathways could elicit behaviors and downstream kind of neurobiological responses that would be possibly interpreted along the lines of something like food addiction.
Yeah. So in this study, since all the food was provided, you didn't see what effect that had on people's choices in terms of calories and what foods. But would that be sort of a logical next step to make this a real world study and see if they therefore, because of this increased activation in the center of the brain, that they are craving more sweets, they're eating more sweets, they're eating more calories? Would that be like the logical next extension?
Right. So one of the wonderful things, but also the challenging things about working with such a well-designed, rigorous study is that you can't really then just kind of let people go out in the world and see what they'll eat if you let them eat whatever they want. So we couldn't directly test sort of the real world implications, but absolutely, I think what we wonder is, if people are on a diet that's high in carbohydrates after they've lost weight, and this is somehow signaling parts of the brain that are associated with reward, does it mean that, at this point after eating a meal that's high in carbs, they're kind of getting a craving for something high carbohydrate? Do they go out and purchase or select a food that is additionally very high in carbohydrates and low in carbohydrate quality? And that kind of leads to this kind of circular feeding, feeding of these same reward regions and propagation of this cycle.
Yeah, and that's a big confusion, I guess, around where you could say the dietary guidelines or the recommendation of a lower fat, high carb diet, where I guess if you say, okay, well, that created this obesity epidemic, then people would come back and say, well, no, because people didn't actually really follow the diet as well as they were supposed to. Well, then you can say, well, maybe it's a diet that can't be followed as well as we think it should be. And this may be giving it, your study may be giving us a reason why, because of that, those behaviors that may come, like you said, from the brain function changes. But interestingly, you looked at the 20% carbs, 40% carbs, and 60% carbs, and there was only a significant difference between the 20 and 60, not the 20 and 40. So why do you think that is? Is there like a threshold level, or what's your assumption there?
We had kind of a smaller sample size than the overall parent study. So we didn't design the study necessarily to look at differences between each of the diets, but in fact, if you kind of look at our figures, the data themselves, what you see is that at least for our primary outcome, the outcome that we were most interested in, which was activity 4 hours after eating, brain reward region, the moderate or 40% carbohydrate diet looks very similar to the high carbohydrate diet, just kind of qualitatively. But in fact, what we then did was say, well, we're going to also look at brain reward activity during a fasting period. And when you look at those data, what you see is a more linear effect. So in this brain reward region called the accumbens, there was kind of a dose-related effect, such that the moderate carbohydrate diet was kind of sitting in between the low and the high, suggesting that depending on the time point at which you look, there might be an effect, such as the more that the higher the ratio of carbs to fat, the more brain activity there is in these rewards.
So it's not like there's just a threshold where all of a sudden it takes off, but it does appear to be a linear effect, like you're saying.
Right. It seems to be
Yeah.
somewhat dependent on kind of where you look at the brain after eating a meal or before eating.
Yeah. And well, I thought that was so interesting how you measured activity before the meal and after the meal, and they both showed changes, although a little bit different. So after the meal shows sort of the acute effect of the reward center and the nucleus accumbens, but
Mm-hmm.
before the meal, there was a higher blood flow and activity in the hypothalamus, but not necessarily the nucleus accumbens. So, and that shows sort of the chronic effect. So do you think that is clinically meaningful, that the chronic effect is somehow different from the acute effect?
In some ways, yes. And to partly add to that story, what we did is we kind of looked at both time points in both regions. And in fact, what we find there is a very consistent story. So if we take the fasting time point as more of the chronic effects, right? So we're not looking at a meal that we've prescribed and looking at the effects between these diets, but it's more like the fasting state. They haven't eaten the evening before. And actually, what we find there is that there is a very similar response in greater activity, both in the hypothalamus as well as in the nucleus accumbens. So that wasn't our primary outcome that we were looking at, but it is
Yeah.
very consistent, which is nice.
Okay. And then one other part of the study I wanted to touch on was the basal insulin level, or the insulin level that was measured before they started their randomization.
Yeah.
And to me, at first look, this was a little confusing because it was sort of the opposite of what I expected. So can you sort of explain the findings, how it related to insulin levels, and why you think you found those?
Those are slightly counterintuitive. So what we found is that if you look just within the high carbohydrate group, there are actual individual differences in the levels of brain activity, such that those with higher insulin secretion after a glucose load um, had a kind of a lower activity in the brain reward region compared to those who had lower um, insulin secretion prior to weight loss.
Right,
And
so let me
it's
interrupt right
counterintuitive.
there for yeah, so let me interrupt right there just to summarize why I think this is counterintuitive, because it sort of suggests the more insulin resistant you are, the less um, that the carbs light up your reward center, which at
Mhm.
first kind of doesn't make sense. So yeah, so
Mhm.
now go from there.
Yeah. So what we interpret this is sort of in relation to prior findings on what's referred to as the reward deficit model of obesity, and it has also been considered for drug addiction, for example, such that when you have a novel reward, such as a drug abuse or a food that is rewarding, um, neurons in this part of the brain respond uh, at really high levels as you consume. But that with repeated exposure, actually, that reverses such that activity goes down during consumption and instead switches to greater activity to cues that predict the reward. That's not super important here because we weren't like showing people food or whatever. But what we think it means is that after chronic exposure to a high carbohydrate diet, individuals who have high insulin secretion have sort of this attenuated effect, such that they need more, almost more of a hit, for example, in order to get that same response in that brain reward region that helps or that results in a feeling of reward. That
Yeah,
makes
and
sense.
I mean, it does. It makes total sense. And it sounds a lot like cocaine and heroin and the drugs of abuse, that you sort of need your fix and you need more, and you can become accustomed to it, and it's sort of like an escalation. So it sort of sounds like this is progress along the lines of carbs as addictive, which carries with it a whole bigger weight of like a burden of proof. And I think it's going to be very hard to say carbs are addictive and treat them as addictive, because there are different types of carbs and because the science is so conflicting. But I know you've already answered the question saying we can't conclude it from this study, but do you think carbs are addictive? Like, does you personally, do you think it should be classified as an addiction, or would you phrase it differently?
I would probably phrase it differently,
Yeah.
mostly because um, I think the language around this is as you've said, just kind of so it wraps up so much in that word addiction. And I think what's helpful is to consider the parallels between them, and to the extent to which can test aspects of it suggest um, that that aspects of carbohydrates are have addictive processes, then as long as that's towards some goal of being able to lessen the impact of that type of kind of the maladaptive effects of having a high carbohydrate diet, then that's helpful. What I don't want to do is kind of go down the line of where it can become very challenging to kind of piece out, what is drug addiction versus
Right.
those are really challenging things to piece apart with certain aspects of study design. So I do think that drawing parallels to the effect that it is helpful in understanding why we eat certain foods is helpful because it provides a model against which to understand.
Right, and the other concept I think of addiction and behavior also is that, some people can smoke 5 cigarettes a week and put it away and not crave it. Whereas
Right.
others, if they just walk near a cigarette and smell it, they have to have it. So there are different levels, and the same may be true for carbohydrates, which complicates the addiction definition as well, I think. But
Mhm.
so then, what is your main take home from the study that you want people to walk away with to say, okay, what can I do with this study to impact my life today?
Weight loss is such a relatable phenomenon, right? So many people are trying to, and it's so frustrating. So I think what this study tells us is that um, how we can generalize it is if you've lost weight and you adhere to a diet which has a higher carbohydrate content, that this can impact brain reward regions such that it makes you crave rewarding foods more. And that might mean that you eat those foods more and you can gain the weight that you lost. Whereas if you follow a lower carbohydrate diet, so aiming more at the 20% that we used in this study, that has less of an effect that might propagate weight regain. Um, and also tells us that there's some of the ways that the brain is involved in into these behaviors that we might not be aware of on a conscious level, but that can really have a big effect of the choices we make and the long-term effects.
Yeah. So if you're the type of person that doesn't have any problem with cravings, doesn't have any problem pushing the plate aside, you're not overeating calories. Okay, maybe it's not as important to you, but if you're the type of person who has cravings, has trouble stopping, has trouble limiting your input and putting away the sweets and some of the things that you crave, then this study is something to take note of because you're probably the person who's got your nucleocumbens being lit up by this, and lowering your carbohydrates could certainly make a difference.
Right. Yeah, I
Yeah.
think that sounds right. Yeah.
Well, very good. Well, thank you first for doing the study and for doing good quality science on this, because I think we definitely need more of that. And thank you for taking the time to join us today. And if people wanted to learn more about your work and read more about you, where would you direct them to go?
Sure. Well, first, thanks for this opportunity. It was great to share our data. We were really excited about this study, and so it's always exciting to be able to share that with others who are interested. Yeah, so they can go to the my lab website, which is holsenlab.bwh.harvard.edu, and find out more about our work.
Great. Well, thanks again.
All right. Thank you.
Well, I certainly thought that was a treat to be able to speak with the primary author of the study and get her input on the study's implications. Hopefully, you found this helpful. Again, please click subscribe and the like button down below. Leave some comments. We'd love to hear what you think. And join us here again for more updates on Diet Doctor News on YouTube. Thanks a lot, everybody.